Okay, for people joining this live stream, we are looking at FindGeometricProof, a new capability for 12.2 that is for generating proof structures from geometric scenes. Now, I mean, my first question here is, how does this correspond to the find equational proof? Yes.
Well, obviously, the logical system is quite different, but I think the argument structure we attempted to model on that.
Okay.
Right.
And the form of proof object.
Yep. It tries to have most of the same properties.
Okay. All right. And the appearance is obviously different, and this doesn't look like it's been graphic designed.
No. And actually, it'd be better if you went through the agenda for example.
Okay.
Mostly the same.
Okay. All right. Find the length here. Let me make this a little bigger. Find the length of the base of a triangle given its area and altitude. So here's a geometric scene with a line, Euclidean distance, a planar angle, 90 degrees, blah, blah, blah. Okay, find geometric proof. Okay, so first question is, what is this doing relative to, okay, so if I take that scene and I say random instance of that scene, I'm going to get a triangle, right? Hello? It's a little weird. Okay.
Run it again.
Does it not have a heuristic for deciding when it's reasonable? Why does it take so long?
It
And also those plus minus look kind of ugly.
Well, we have a separate meeting to discuss that.
Right. Oh, well, this thing seems to be spitting out degenerate stuff. There's sort of a heuristic to try to draw, draw good non-degenerate polygons and such, but that does run up into run against, in a sense, making sure that there's full generality allowed. So it's kind of a fine line you have to walk to.
Yeah, what is even the area of? Is that the?
Oh, that's probably the problem. It should be area of a yeah, that should be triangle YZX, I would assume, or at least for the.
Yeah.
Yeah, that's a good point. Yeah, there we go. I was gonna say, it's like that one it should be able to handle.
Okay, all right, fine. Okay, so now I'm totally confused here. So this is a scene, and can't I just ask it? Okay, so that's a random instance of a scene, but here what is this proof? What's that a proof of? It's a blank there.
That's the statement that you wanted to prove, and it's you could tell it. What?
Well, I mean, why don't I tell it the Euclidean distance is equal to some particular number?
Well, you could do that too.
But this is if the question is find the Euclidean distance, it both finds it and tells you why.
But and that's actually not a proof. Go ahead.
Well, sometimes you want to put a question mark numeric Q on the end of it because you want to make sure that you get the first answer, which is a number.
Yeah, well, okay. I don't understand that statement, but if you already know the answer, yes, you can put in the answer, right? So, but this is just being nice to you and saying, well, try to prove a statement of the form this Euclidean distance is equal to something.
Okay. All right. Okay, fine. So this is the analog of show steps for geometry.
Yep.
Do we have any hope of being able to enter the inputs in Wolfram Alpha?
Not as text.
But what about as drawings?
Under discussion.
Okay. I notice that Noah is here, and I know he has drawing tools that work in the desktop front end at least.
Right, we discussed with Jan.
Okay.
Yeah, we have a meeting on this tomorrow.
Oh, okay. Okay. So what is this now? So okay, so then this is a proof written in some human readable form. That doesn't seem very computable. What happens if I just say, let's find the proof here. Okay, so let's say I say PF of proof graph.
So the embedding of the proof graph unfortunately changed recently in the prototype build. So it should just have straight lines, and it should be a layered graph.
Okay, can I just pull the graph out and let me just do that then?
Yeah, I'm not sure why the proof graph is giving us something with tabs, which I can't read. Can you maybe increase the
What doesn't help?
on one more level?
I don't think it'll help, but yeah, I can. Well, maybe it does.
Yeah. Facts, tooltips, no labels. Oh, it gives you different choices. That seems excessive, right? I don't think we do that for normal proof objects, do we?
No, we do not. Although it's an interesting idea. Jonathan, I don't know whether you would like to comment on that.
We could support it. It never occurred to me.
Yeah. Oh, for goodness frigging sake. Okay.
I believe if you paste it into an older version, it will look better.
Okay, so these are givens. This is interesting. So how does this relate? I could sort of imagine what happens if we reorient this. I mean, if we say here vertex coordinates goes to automatic, right? That's probably what I need to say. Oh, whatever. Can we make sure this is reported as a bug? Is this a bug in the graph layout stuff or something else?
I haven't determined that yet.
Well, who knows? Okay, in any case. Okay, so this is now showing the dependency. Now, is it ever going to do anything non-trivial in this graph?
Sure, it's a graph with a source and a sink, and any kind of branching directional graph.
It can happen. Anything can happen, is what you're saying.
Yeah, of these kind of proof graphs that you're familiar with.
So
that's a bug.
What's a bug?
The fact that there's a node there that doesn't seem to come from anywhere.
Well, it's also got a plain geometry, synthetic geometry proof stump wrapper.
Yeah, there's a few things that are not quite right in this recent build. I'm sorry.
Okay, but fundamentally, I mean, like all this, empirical metamathematics on Euclid that I've been doing, this should be drawing the same kind of graphs. Is that right? That say to prove this theorem, you need to have each one of these nodes as a theorem. Is that true?
Yes.
So to prove this theorem, you are contributing from, so there are also presumably axioms of Euclidean geometry, which are not being shown as, so onto each edge, you are applying what are you applying onto that edge to make it happen? In other words, a previous theorem, how does it insert itself into this picture?
Not a given theorem. You just mean something that's previously proved.
Yeah, something that's in Euclid's Elements, for example.
Well,
see, I don't think it's anywhere, right? This is a synthetic prover, right? I don't think it's anywhere near that constructive, right? So yeah, so the edges are generally, you know, the postulates, that's the word I'm looking for, sorry, are generally, you know, postulates or maybe well-known theorems from the elements. And they sort of take you from one sort of fact to another fact.
Well, what you're saying is this is a computational prover, so to speak, as opposed to a formalistic prover. I mean, a formalistic prover would build up from the axioms and prove everything. This is something where you're saying, I already know a lot of geometry. Now I'm going to use what I know to establish some result.
Correct.
Very heuristic.
Right, and it's designed to try to look like a two-column proof you would see in
Grade geometry.
Yeah.
US.
It's more what humans would do, not from first principles.
Right.
Okay, so can I get that for this PF chords thing?
The graph?
No, not the graph. The written out. What? How do I get that written?
Oh yeah,
out?
the proof notebook camel case. Yeah.
By the way, I don't know where this design comes from, but obviously it needs work, right?
Exactly.
I was going to warn you that there are still a lot of rough edges in the code. This is just one of them.
So I mean, this here should just be a gray number. It should not say no at the top. Obviously this yeah, I mean the fonts, the colors, etc., are all kind of bizarre. So, I mean, this is essentially, we're synthesizing text much like we do in show steps for something like, you know, calculus or algebra or something. Is that correct?
Yeah.
What does this mean? By 7 distance AE by algebra on.
So just the generic way we say we used algebra. Hopefully someday we'll have the Wolfram Alpha show steps to explain this a little better. But this is just dividing by 7.
Yeah, I could see that, but I don't know what I'm trying to figure out whether there's a little blot on my screen or whether, no, it moves as I scroll. So that's not a dot on my screen. That's a dot somewhere else.
Okay.
I thought it was just a piece of dirt on my screen. Yeah, and also I don't understand this distance AB. Don't we have a symbol for that? I mean, I mean, there's just so many things wrong with this.
Okay, so yeah, we had talked about this, and I should have mentioned before that all the formatting of the geometric statements is going to be totally replaced with what Ian has now built. So the text, yeah, I'm working on that.
What has he built? Is it a traditional form version of this or something, or what?
It's not exactly traditional form, but yes, it's more traditional formy looking. And so, right, although if we're going to use it here, I mean, the question is what Ian built is not interpretable. So, you know, if somebody copies out from that notebook and pastes it in, it won't evaluate anything. So if that's a bad thing, we need to rethink how Ian's stuff works.
Well, okay, so proof function doesn't exist here.
Actually, I did build one that works, but we decided I shouldn't spend time on it because it's kind of a silly thing.
Yeah, there are no system functions to do this functionality. Right, so it would just be a bunch of bizarre internal context things to. Right, it just didn't make any sense.
All right, so big picture here, we would like to be able to generate from Wolfram Alpha kind of Euclid style after 2,000 years. we want to be able to generate automatically these kinds of proofs. Is that the basic point? I mean, so I can pick a random proposition in Euclid and I can type it in, or I can somehow draw it, and then then we can generate that proof. Is that the idea?
Yeah.
Okay. So let me just understand the different steps here. So one step is I've got to be able to draw the original thing, right? So I'm drawing something like this. Is that correct?
You can draw it first. There is a drawing tool.
No, I understand, but we're not realistically, people are not going to, at the Wolfram Alpha level,
Right.
they're not going to enter something like that, right? Mm-hmm. Nor are they going to enter kind of a verbal description that will sound like, some real estate plat survey that says, go this distance in this direction and take this angle and so on and so on and so on.
Right. Well, although they could conceivably type in something like, let A be a point, let B, let AB be points, let, the line AB, blah, blah, blah.
Okay, but without some kind of auto-completion mechanism, I can't imagine we'll be able to make that work. In other words, unless we go into a mode where you're typing structured text, that just seems completely implausible to me, because these things will be quite long, and there'll be many, many ways to get lost.
I guess that's true.
I agree. Yeah, the structured text is something we have discussed.
Steve is suggesting publishing Euclid with this set of notebooks. We have, in fact. Should we show just to show that we actually have? Anybody want to show the computable Euclid thing under development? Somebody sends me a link. I'll put it up there. Yes, we are on that subject. Yeah, we're on that idea. Okay. So. What was I saying? Yeah. So okay, let's just understand the workflow. The workflow is somebody draws this diagram. We have the ability, they put this line here, they have it, they click something that says that's a right angle.
Okay.
I mean, is that what we're planning, or is that, that seems plausible, and then they're going to ask, and then what do they want to do? They're going to, it's like what we had done years ago with, you give an image and then you ask questions about that image. Is that right? Now, the other thing that people are going to do, because unfortunately, today's students, he says, because the old are always criticizing the young, are
especially Greeks.
I think it's the human condition has been the same for a very long time. In any case, people will just take pictures of geometry questions. What do we do in that case? We've had a number of experiments trying to do natural diagram understanding. It's been pretty difficult. What are we imagining is going to happen in that case?
I don't know that this is the right set of people to ask, right? That's a heavy-duty image processing.
Right, but I'm just trying to understand the complete workflow here. So the workflow is somebody draws a diagram and they ask questions about it. Is that correct?
If we're talking about alpha, right? We also imagine Mathematica users might be interested in this, in which case they can just type in a geometric scene. Or once we have somebody to finish working on the drawing tools for geometric scene, they could draw a geometric scene.
Right.
Okay, but realistically, what kind of computation would involve, when you write these kinds of things? Okay, so we've got a bunch of primitives here, which are, when I'm trying to solve an actual geometry problem. Okay, I've got my, my piano, and I'm trying to get it through these doorways, right? Is it realistic for me to, under what circumstances can I really turn it into stuff like this?
The latter one, not, because it has basically one free parameter, the position.
Okay.
Like you're moving things, it's a totally different ballgame.
Okay, all right. But so what class of things can I enter? Clearly Euclid thought it was interesting, although famously, told people, I just read a story, okay? was by an assistant of Isaac Newton's, apparently, who had worked with Isaac Newton for 5 years, and said the only time he saw old Isaac laugh was when somebody had he had given somebody a copy of Euclid, and the person said, asked him, "What is this good for?" Apparently, then he laughed. So you can read that any way you want, but okay. So the question here is, what, beyond kind of Euclidean, beyond the sort of the exercise of doing proofs and so on, what are the industrial uses of this? Do we understand that? What are the things where?
So for the drawing, there's geometric constraint solvers are a big thing in CAD drawing, and I've actually been approached by some people at the previous tech conferences about.
Indeed, right. So indeed, that's a real thing.
Right. Now for FindGeometricProof, right, I think we're in the land of,
School, not
school,
production.
not industry.
Right.
Right. But for geometric scenes, that's something where that's something where we could imagine much more sophisticated things, where we're trying to give constraints and so on here. Okay, but let's go back to proofs. So, one of the things that we have learnt from find equational proof is that, we originally produced find equational proof in an attempt to make somewhat computable what had otherwise just been a narrative story of proof. What has happened more recently is that, we've now been actually starting to compute with those proofs. And we've discovered that we did a pretty good job of making the, well, I don't know, Jonathan might want to comment on this. I would say the proof graph, which we originally made just for decorative purposes, has turned out to be a really very useful thing. The proof,
and whether it was intentional or subconscious, makes some nice connections with multi-way stuff and things, as you've been saying.
Right. But so, for example, the proof data set, I would say, is less convincingly useful at this time. I mean, in other words, just to remind ourselves what we get in that case, because I'm trying to understand, I'm trying to think ahead, how are we going to use these geometric proofs? So, for instance, I mean, if I were to just pull up, random example here. Let's say, what do I have here? Here I have some random example. Oh, you don't want to use Scheffer's axioms. They're huge.
Use axiomatic theory.
Yeah, okay, fine. No, I'm just joking. It's just snobbery about axiomatic systems for Boolean algebra. Okay, so anyway, so we get the proof data set here, and it's a big hairy mess. And the question is, what would we imagine using this for? Because so far we've never used it for anything, really, other than just looking at it. And that only rarely. And by the way, I would like to comment that a general design thing is that these things here are essentially representations of the application of rules. And I'm convinced that we need a construct called replacement that means how a rule is applied. That is, if we say, and I'm just trying to understand that because I'm trying to understand it in this case as well, right? So this is, go ahead.
The substitution lemmas are those. The critical pair lemmas are a bit different, right? They're really like two replacements and a statement of most general unification.
Yeah. I mean, the fact that we have those two kinds of things here is, I think, somewhat arbitrary. I don't completely know, but anyway, so here, I'm just concerned, what is the analog of proof data set? Do we have a proof data set here?
There is, and there's a computable proof. Proof data set, I think. Yeah.
Okay, so that has a lemma. Okay, that's nice. So that has something which is in the same format. So basically you're generating lemmas here. If I say PF chords, they're not very exciting lemmas, and that's a bug, right? Is that a bug?
Yes.
Shouldn't be exposed.
Okay, but what is it? I mean, it's just something which was a wrapper that.
It's a constructed radius is what it is.
But how should we represent that?
That's been a discussion, but what I'm doing now is just using C for constants and P for points with a integer index.
So these have to be uniqueified objects.
Right.
Is that something that you run into, Jonathan, in your proof thing? You have, I think, x1, x2.
Right. So we have generated variables, and we use essentially De Bruyne notation for indexing them. That's the scheme we've been using.
In which context do they live?
I think they're equational logic backtick.
Oh,
I thought it was a no-go.
Yeah, that's a kind of a no-no.
I may be wrong. I can't. It's been ages since we designed this.
It seems to be just in system context.
Yeah.
Well,
Which is
certainly
also
you
kind
of
mean
worse.
global.
Global.
Yet
no,
worse.
Yes, it's yet worse. I mean, listen, the story of generated variables. I mean, by the way, of course, in our physics project, we are all basically generated variables. You know, the whole freaking structure of the universe is a bunch of generated variables produced by, you know, what we can think of as lambda expressions that have their innards hanging out. But we don't have a great way to do this. I mean, you know, the only ways we have to do this are using unique, which is pretty horrible. I mean, I don't think we have a way to do this.
I mean, so for the drawing the geometric scene, I have to generate variables, and I can't use unique because I need the generated parameters. If you run if you run random instance on the same scene multiple times, it needs to have the same generated parameters. So I basically use capital C of and then a bunch of strings.
Okay, but so this is analogous to what happens in a differential equation where we generate, you know, these x1s are similar to the c's that we get from solving a differential equation, right?
C's or K's.
Yeah, but I mean, those things are, that thing there is, in fact, in reality, that is that, right? It's a print form of that. So we could imagine having a similar kind of thing which has some print form that is a formal variable. I mean, we've had the same issue in axiomatic proof. I mean, axiomatic theorem, you know, axiomatic theory, where we end up with these kinds of things, right? Because we want these to be variables that can't have values.
But you can't subscript them. But you can, but then it's no longer what you wanted, probably.
What are you saying there? You mean
like you don't want subscript formal a comma 1, you want formal subscript a1.
Yes, right. Boy, right. I mean, well, unless we made all of the axiomatic theory stuff just ignore subscript. In other words, unless we made it so that this construct would be always treated as a symbol, which I don't think would be crazy. You know, treat that as a.
I think that's dangerous because you can make assignments to subscript.
Right. Formal A is protected, but subscript of formal A1 is not.
I know, but you know, we gotta draw a line somewhere, I think, here. I mean, in other words, so look, I mean, what we've got here, okay, we've got generated variables of various kinds. Okay, so this generated variable here is, I mean, arguably.
What about giving C multiple arguments where, or maybe even an option that says how it formats? Then we don't need a new symbol.
You mean we actually have C's in here, really?
really are C's, but they like appearance goes to row K, whatever you want.
Scary. That's truly scary.
Right. Well, so do something like integrate x, comma x, comma y.
With option, I assume.
Oh yes, generated parameters goes to automatic, I think, or probably C. Oh, do I guess do C. Right.
So
Okay,
that knew to generate a C sub 2 rather than to just try and encrust C sub 1. Is that the point you're making?
Well, I was making a bad point, but yes, in this case, these are right. These constants are sort of not constants, right? They're
so one
functions.
argument, one possibility would be that we have a thing called formal or formal variable. We would just formal, just say formal, and then it has things like A1 or whatever it is, right? And that essentially what this means is it's something that you can't assign to. And,
right, but you can't also solve really with it.
We could make solve deal with that. We could make this in the functions that matter. We could make this be, and I mean, if we did that, that would have the advantage. I mean, we could get rid of, for formatting purposes, we could get rid of all those nasty dots and so on. I mean, I think we're going to wind up with something like this, because I think, you know, and if we did that, we can have a generated formal object here. What do people
One disadvantage this might have is frequently, say, in mathematical identities, you don't want them to be evaluated. But this one, I would guess, needs evaluation to behave properly.
No, it could just have formatting.
I see.
To behave properly. I mean, I don't know why we didn't do it this way in axiomatic theory. Maybe Jonathan remembers. I mean, we discussed this.
So we have discussed this type of thing other times. So in my opinion, the main problem here is that, in my opinion, there is no way of avoiding unique, because if you have a formula with dummy variables and you copy it from some part of the notebook and put it somewhere else, that formula may have again format A1, and then we are screwed again.
And another thing is, like, for mathematical function identities, we use them as arguments of pure function, but they must be symbols. They can't be compounds.
Oh gosh, yes. Well, I mean, we could fix that. You know, look, at some level we have to bite the bullet and really solve this. But I mean, go ahead.
My suggestion for this, and this is the thing I've used in Exact, is that I use dollar variables internally, but before those variables get printed, they are replaced by nice variables. And so the users keep seeing nice variables, but there are never collisions because internally it's all unique.
Yeah, but that doesn't solve your problem with the chameleonic problem. Back in SMP, I had these crazy things called chameleonic symbols, which had the property that every time they were used, they would have a different name.
Right. And what's bad with that?
It was unbelievably confusing and disastrous, but other than that, it was fine. I mean, it was just utterly obscure because you would get things. Go ahead.
So imagine that internally you have $1, $1, a million, $2 million. But before they get printed, they always get printed ABC. And you use them again, it's ABC. And you copy that, you put it somewhere else, you put two of them, they will be ABC, D, E, F.
So you mean they look as if they collide, but they don't really collide? They
never collide because they in a session, each of these variables is always unique. It's only when they are going to be printed.
Right, but you can never type them in.
Right, exactly, because these things are generated. If you print, I mean, you can print A, and then the system is intelligent enough to realize that when printing, the $1 cannot be replaced by A because A is already used.
Right.
know,
Well, that
some-
means you must have some outer wrapper that knows to do this replacing.
Exactly. What I do is that I do $preprint equals some function that handles everything.
Yeah, I don't think that's a general solution.
right.
It's a general solution, but it's a solution you need to be aware of because you see A and internally it's $1 million.
Right. So, I mean, one thing to remember is we could use a letter-like form, not dollar, as our convention for how we, we could even have something, we could have something that looks a little bit better than a dollar something or other. I mean, it's never going to look great, but we could at least have a different character there. If we really want to do it that way. But I mean, I think, I don't understand this. I mean, basically, if we're going to use it here, so in these formulas, the x1 in this formula is different from the x1 in this formula, right? They have nothing to do with each other.
Right. And the point is, what happens if I want to combine both formulas? So I copy one, I copy the other one, and put them together.
Yeah, I mean, then you're toast. Yeah.
By the way, I should say that the solution that Jose used in Exact is essentially what we're doing here. I mean, if you assign x1 to something, it won't change the internal behavior of find equational proof. It will just change the way that the proof data set is typeset.
Sorry, say that again, Jonathan. Sorry.
So exactly as Jose said, within find equational proof, we're doing the exact solution. Everything is unified within the actual algorithm. It's only when it's returned that we send things back to pretty variables. So if you rerun that proof, but you set global x1 to be 4 or something, it will still run. It will work fine. It's the only thing that will change is the way that the proof data set typesets.
It will avoid that or not.
Yeah, I think it will. Well, let's do the experiment. I think he's saying that if you just set x1 equal to 4 and then reevaluate the proof data set sub-value, right?
Reevaluate find equational proof, and you'll see it doesn't change it still proves the thing correctly. Nothing about the behavior will change.
Oh, sure. But then the proof data set will have garbage.
Yeah.
Yes.
Okay. Yes. No, I understand. So your point is that it's only in the construction of the proof data set that you insert these things.
Right. Yeah. I want to make it clear that we're not. Yeah. The internal algorithm is not at the mercy of the global context. Right.
Look, we have the same problem. And, the fact that I had this problem 40 years ago in SMP is kind of telling. We have this problem of formal variables that have to get renamed whenever they're used. We should just solve this problem once and for all, either by, essentially, the dollar variables thing is unique, is using unique, right? And so the issue is
right. So what the geometry folk are doing is different, right? They're actually embedding the information in of what that point represents into it. But
okay, so I've got a crazy suggestion. Okay, what if we pick a character? Okay, I'm going to pick a wolf. Okay, what if that thing just formats as X? In other words, there's a letter-like form in the symbol name that is basically a signal to the pretty printer that says, just don't show everything after that character.
But for the say geometry, you won't say something radius 1 and radius 2. So row 1, row 2 with subscript. This wouldn't work.
Well, okay, fine. I'm gonna be even more hacky. Okay, I'm gonna be even more hacky. I'm gonna put in other words, we're basically using the fact that we don't want to avoid it being a symbol, right? So I'm gonna say I could do this. I could say this, blah 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 blah. So in other words, I could have two pieces. I could have a piece where it stays as a symbol name. It's a symbol. It walks like a symbol. It talks like a symbol, etc. But it has that subscript burnt into it. And this simply formats as X sub 1, and it ignores this last part.
That's pretty dangerous. I mean, the assumption that, symbols typeset as plain strings is hardwired in a lot of places in the system. So
Well, I mean, not every symbol. Look, let me point out, as we deal with, what about a symbol with a Hebrew characters in its name, right? It's not a, when you say plain string, right, left to right, right to left, et cetera, et cetera, et cetera.
Yes, but it's still, but 2 boxes of it produce something that is string Q, and you're talking about this, giving something
you're
that's a
complaining about
subscript.
the subscript piece of this.
Yes.
I see that. I agree. That might be an issue.
I mean, I don't understand why we don't just, I mean, if all we want is something that looks pretty, then why not just stick it in an interpretation? And so the underlying, it's whatever it is, and then you make it look however the hell you want. Right? I mean, you're talking as if we didn't solve this problem 24 years ago.
Okay. Well, what are you proposing? I mean, so let's say axiomatic theory, for example.
Right. So instead of replacing all of those things with, a literal symbol x1, it constructs interpretation of, whatever display it wants, comma, the underlying variable.
Isn't that the other way around? What order of arguments does interpretation?
The interpretation should be at the end.
I see. Right. So okay. So interpret it as x. Okay.
Right. So this could be subscript of x1, but the interpretation x $12345.
Okay. All right. So, but let's say that's not good enough, though. I mean, if axiomatic theory returns a thing that is of this form, it will be indigestible to computational functions, won't it?
No, it's interpreted as x $2345 blah blah blah.
Okay, so if I say this thing, let's make a table of those. Probably not the best way to do it, but let's do it this way anyway. Okay. Well, that's pretty good behavior. But now the problem is, here's the problem. Let's say we take axiomatic, let's say we take this. What is that now? Is that? Yeah, so I can't take those as module variables, for example.
Right. Yes. I mean,
unless we made that work, which we perhaps could. I mean, that could be the lesser of the evils, to make module work with interpretation. In other words, to allow module of that x1.
Right. I guess we're right. Well, see, the thing is, you literally typed in the interpretation rather than copying it, right? So if you had copied that out, then it would have been interpreted as x $23 blah 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 blah, right? So if you take that %74, I think it is, or can't quite read.
It's 600 and something, but whatever.
Okay, the 674.
Yeah.
Right.
Okay.
And you make a table of that.
Table of %674.
No, not of %674. Take the output.
I mean, copy the output.
Yes.
So you're saying, okay, so if I were to ever copy, if I saw the output from axiomatic theory and I were to ever copy it, I would get this kind of garbage.
Well, as long as you left, yes, if you left things unadorned.
What do you mean by unadorned?
Right, as long as things didn't. Right, if you did something that returned it unevaluated, yes. Right. I mean, this is something you could use in module right now, right? You
yes,
could do.
But I understand that, but it looks extremely ugly. It lost its annotation. Look, the fact is, at some point here, there is some heavy lifting that has to be done. We've got module variables, we've got pattern variables. We intended for version 2, maybe 3. It was a 14-hour design review attempting to put subscripts into pattern variables. And eventually we had it almost implemented in version 3, I think, and we pulled it out at the last minute because there was a bunch of semantics that was just incomprehensible. And what we had there was basically, so what that was, among other things, was symbols whose names, so for example, let's do this. Let's say I take this thing, how do I make that into a string with that form? I just say, you know what I'm asking? If I say quotes that, right?
Mm-hmm.
Okay, so now I say symbol of that. What?
Yeah, you can't do that. That's not a valid.
Oh, that's right. That's what we tried to do for version 3.
Mm-hmm.
There is probably code somewhere that tried to do that. That tried to allow a symbol whose name is an arbitrary string, including a string with inline formatting.
Yeah, I've seen vague traces of that code, but it's no, when fixing bugs in make expression, but I don't think anywhere close to functional or.
Well, I know that was that was 1995,
probably.
Yeah, 1995. Right. Look, we do have to solve this problem. We've circled around this problem for nearly 30 years. We really should solve it.
Okay.
And that will, going back to this, and we're going to need to wrap this particular meeting soon. I'm a little concerned about this. I'm a little concerned about this functionality that is, it looks nice. I'm just concerned about how we really use it for things.
It is definitely not so much. Yeah, go ahead.
Well, I was going to, you see the all in the first argument here, and I'm not sure what it's returning.
It's returning random facts that it knows.
Yep.
But is it proving multiple things? I don't understand. Or is it just stating multiple true things?
It just creates a long list of true facts until it either runs out of time, or it's your max iterations, or it thinks it's found it all. It can't. It iterates and doesn't find anything.
We've run into two issues here, which are, one is the style of computing that just says, essentially enumerate a multi-way system and start producing facts from it is not what we're used to, which is what you're doing here, effectively. Just find all these random paths in the multi-way system.
Well, it's kind of strategic.
I understand. It's similar to find instance, for example, which will try and find solutions to equations, but it has no guarantee to find all of them. That's one thing. We're also dealing with the problem of, variables and formal variables, which we just got to solve.
The first problem for this case is maybe not so bad, because for practical purposes, there's only a finite number of things what you, at this level at least, want. You want distances, areas, orthogonalities, coinciding intersections, and related things.
I'm not sure we should. Find equational proof doesn't have a one argument form, right? I'm not convinced we should have a one. This is effectively a one argument form, right? I don't think find equational proof takes all as the things to prove.
Well, in fact, find equational proof, that is exactly what multi-way system does. Is it just goes and just trees out all the possible theorems, right? Find equational proof in principle could take, it would be typically infinite, right? It could take a quotes one argument form with a max items option that just says find true facts, right, Jonathan?
Right. The analog would be equational multi-way system with the with the substitution lemmas, critical pair lemmas switched on.
Is that some function in the physics project? Because I've never heard of this function.
Yes, it's a function in the physics project function repository.
Yeah, it's a WFR thing.
It also happens to be extremely new, Jonathan, like less than 3 days old.
Okay. Oh dear, how have I missed it? I'm sorry.
Sandra is commenting that all these proofs are in a sense second order polynomial solving. That is a true statement, right? I mean, these are circle and circle and line, ruler and compass type constructions, but they're complicated. They're complicated, coupled, large numbers of coupled quadratic equations. Is that correct statement underneath?
It is correct, but that is not what FindGeometricProof does. That's what geometric solve, is that what we're calling it, would do?
But even this is not quite correct.
Yeah, I mean, it's
which
right.
part
Well, I mean, they have lots of radicals in them, right? So it's not, once you actually,
for example.
Right. So, it's not pure quadratic systems.
Okay, but question, what was this find geometric? I mean, geometric solve, what is that?
Geometric solve is that's a new function that basically no one outside of the synthetic geometry team has looked at yet. The point of this function would be you input as the first argument a geometric scene, and then the second argument something you want to solve for, either a quantity in that scene, or just say length of between A and B, and it will try, and if that quantity you're solving for is uniquely determined by that scene, it tries to return it.
Okay.
Basically things that are coordinate invariant. So that's synthetic that we...
Yeah, I understand.
Or if coordinates are supplied in the first argument, the geometric scene, then it will just use those coordinates.
Listen, we're running out of time. I have a couple of practical points. By the way, Ethan on the live stream is pointing out that this should have a progress monitor. Does it?
No.
It'd be nice if it did, because it's going to take it a while. Okay, let's be practical here. This is a very complicated function with a lot of tentacles. What are we going to do for 12.2? I have a possible suggestion. Maybe we should just have this code and, basically expose it in the function repository rather than exposing it in the core system. Because I think the design of this, I think there are many design issues here, and I don't think we're going to be able to solve them all. And, I think there are issues about these formal variables. There are issues about how we use this computably and so on. I mean, Michael, you have...
I think that's a good idea. I mean,
yeah, and to be perfectly honest, the state of the code is not such that I can believe it can be made shippable in 1 month. So, so that sounds, if it's just backing a function repository function, that sounds like a much better starting point.
I like this also better. I mean, it's already useful, and it will be useful for teaching, but it might not quite have the production strengths we aim for.
Fair enough.
How would you, like, if you have never mind. Like, for a function repository item with, the thousands of lines of code.
No. We ship
offline. Yeah.
Right. We ship it in the kernel in some hidden context, and then we have a function repository function which basically just maps the top level stuff to the hidden function.
This is what we do is say virtually everything for Wolfram Alpha notebooks.
Right. Or we do that in or we ship a bunch of code in the function repository. It doesn't really matter. The function repository is as much an exposure mechanism as it is a code repository for these kinds of functions. All right. And look, we need to have a meeting about these formal variable things. This is such a, I have to say, I will tell one little story because I can't resist it. A few years ago, I was looking at these big book about lambda calculus, big thick yellow book about lambda calculus, 1,000-page book or whatever it is about lambda calculus. Indeed, yes, indeed. Who we'll probably be talking to on some live stream about the physics project in not too long. But in any case, I think Christopher and I were looking at this, and the question was, in all of these years of lambda calculus, right? All these things where you're got variable renaming, and lambda calculus has exactly this variable renaming issue, as do our functions, et cetera, et cetera, et cetera. Like in nearly 100 years of lambda calculus, you would think somebody would have solved the variable naming question. Okay, so you go through this whole book. It's a huge mess throughout the book. At the end, there's the grand climax where it talks about variable naming, and its solutions are absolutely insane and utterly hacky. I mean, like this De Broglie numbering thing and so on. They're all just, basically nobody has solved this problem. And I mean, the only person who solved this problem is in a sense Schoenfinkel with combinators, back in 1920. Where there simply aren't any variables. The problem with combinators is nobody can understand what you get. Anyway, I think that yeah. All right.
One remark. So while I totally agree that this renaming is an important one, from a practical point, if you look, say, comments of people, the x1 something is maybe even more important.
What do you mean x1 something? You mean
like you see so frequently people have a differential equation and then make x subscript 1 as an initial condition, but what they mean is x subscript 1 as something independent of x.
I see.
Say x of 0 is x1.
Yeah, well, that's exactly what we wanted to do in version 3 with the subscriptive variables.
Right. But it's not quite a renaming, it's a slightly different problem.
No, that's right. It's look, we could solve this problem if we broke the idea of symbol names being strings. No, they could still be strings, but they might have to be strings that have more complicated display forms. That would solve the problem. The problem with that is canonicalization. That there are multiple different ways to get something which has the same appearance. With a string, you at least imagine, apart from invisible characters and other pathologies, you imagine that different strings have different display forms and so on.
Right.
Ethan is suggesting that GPT-3 could infer informative variable names for code transformations. Yes, we have tried some of these kinds of things. It is not a bed of roses. In fact, it is completely crazy what it does. Yes. Oh, there's a question here from Ethan, which we might be able to answer about update on the Packlet repository, and irrelevant to this discussion, but it is moving along, I believe. I think we'll probably have a review of it quite soon. I mean, look, I do want to just highlight this point about the different style of computing that is the proof style of computing. And I think we're slowly understanding kind of, and that style of computing is more the kind of prologue logic programming style of computing where you just state certain constraints and then you say, what's true based on these constraints? Or that's one version of it. The other version is, here's the thing that I'm trying to get to, show me the path by which you got there. And I think that's something that so far, it's actually I would claim this is actually really quite an interesting thing that's coming out of the physics project, that the analog of a proof is a path like a geodesic in space-time. And that makes us care more about paths and therefore care more about proofs, and therefore makes us want more to have proofs be computable things. And that's sort of leading us into this domain where we really have to have a proof be computable, because this kind of thing here isn't right now very computable. We haven't used that. I don't know any functions that take the innards of this and compute with them. And that's the issue there. Anyway, very interesting stuff. All right, I need to go. I forgot to have lunch today, and I am just incredibly hungry here. So, and I have another meeting. All right. Too many exciting things. All right. Well, yeah, Ethan is saying that these lines should be rendered with LaTeX. They're certainly super ugly here. They'll get a lot better. All right, great. Thanks, guys.
Thank you.
Okay.
Thank you.